We are continuing our trigonometry lessons. We're going to continue to use stuff from sections 9.4 and 9.5 that we did not get to last time, specifically the word problems. So the main features of word problems with trigonometry are going to be the words angle of elevation or angle of depression. So the angle of elevation is the angle that if we started with a horizontal line and I looked up from that line, I'm elevating that angle. That's the angle of elevation. Whereas if I'm standing up somewhere higher and I start with a horizontal line and I look down from that line, that would be the angle of depression. So the key thing to know for angle of elevation and angle of depression is that they are always formed with a horizontal line. It could not have been formed like here, right? That's with a vertical line that angle has been formed by. Also, because horizontal lines are parallel to each other, the angle of elevation and the angle of depression are alternate interior angles, which means they're congruent to each other. So if you're given one in a problem, you can actually draw your picture involving the other one, all right, as long as you're forming the angle with the horizontal line. So for our first example, we have Leah wants to see a castle in an amusement park. She sights the top of the castle at an angle of elevation of 38 degrees. She knows that the castle is 190 feet tall. If Leah is 5.5 feet tall, how far is she from the castle to the nearest foot? So this is a problem where Leah's line of sight is above the ground. She does not have her eyeballs on the ground when she's looking at the top of this castle. Her eyeballs are in her head when she's looking at the top of this castle. So the triangle that we're forming is kind of hovering in the air a bit. There's some space underneath it of 5.5 feet. So this 5.5 feet that's hovering underneath the triangle was already included in the height of the building, the 190. So I would have to take away the 5.5 to find out the height of just the triangle. So if I do 190 minus 5.5, I get 184.5. I know the angle of elevation was 38 degrees, and we're looking for the horizontal distance x. So this is the triangle I'm actually going to solve in. I'm not going to solve using the 190. I'm going to solve using this 184.5. So if this is my angle, that's O and A. So O and A is tangent. Tangent 38 equals 184.5 over x. When the variable's on the bottom, we're going to divide. So x is really going to be 184.5 divided by the tangent of 38. So on my calculator, 184.5 divided by tangent 38, I get 236.15, but they say to the nearest foot, so 236 feet. All right, so this is one for you to try. I'm actually going to draw a picture for you on here if you'd like to pause after I've done that. We have at the circus a person in the audience at ground level. So their eyeballs are in fact at ground level. Watches the high wire routine. A 5'3" tall acrobat is standing on a platform that is 25 feet off the ground. So we have a platform that's 25 feet and an acrobat on top of that who's 5'3" or 5.25 feet. We want to know the distance the audience member is if they're looking up at the top of the head at an angle of 27 degrees. So here is a rough picture for you to try. Answers are posted online. I would recommend pausing and giving it a shot. For example 2, we have a lifeguard watching a beach from a line of sight 6 feet above the ground. She sees a swimmer at an angle of depression of 8 degrees. How far away from the tower is the swimmer? So we're looking for the horizontal distance. We know that this height here is 6 feet. We're looking for this. This angle is the same as this angle. This is the angle of elevation down here. This is the angle of depression. So I could really move the 8 degrees here, and now I could use this triangle down below. So we have O and A, which is again tangent. Again, the variable's on the bottom, so x will be 6 divided by the tangent of 8. and I get 42.69. They didn't specify, let's say 42.7 feet. So here's a problem for you to try. Pause if you'd like. The answers are posted online. For example 3, your school is building a raked stage. The stage will be 30 feet long from front to back with a total rise of 2 feet. You want the rake, or the angle of elevation, to be 5 or less for safety. Is our stage within our desired range? So now we're looking for this angle. We know we have the O and the H, so that means x will be the inverse sine of 2 over 30. I'm not using the 5 that they gave me in the problem just now because I'm going to compare my answer to the 5. So if I do the inverse sine of 2 over 30, I get 3.82. So the question is asking, is the rake stage within our desired range? Yes, it's less than 5. So here's try 3. Once again, I will draw the scenario for you, and then you can give it a try. This is another one I recommend trying. So we have the crossbar of a goalpost is 10 feet high. If the field goal attempt is made 25 yards, this is 10 feet. This is 25 yards, which is blank feet. And it clears the goal by 1 foot. So we're making it over the goal by 1 foot. What is the smallest angle of elevation to the nearest whole number degree that we could hit this at so that it clears the goal by that 1 foot? Pause. Answers are posted online. All right. For example 4, we're in a hot air balloon that is 600 feet above the ground. You could see 2 people. The angles of depression to person B and to person C are 30 degrees and 20 degrees respectively. How far apart are person B and C? So ultimately, we're looking for the distance between B and C. The 30 and the 20. Angle B, for lack of a better name for angle B, because I can't call it anything else, the angle here at B is going to be bigger than the angle here at C, because the further away you pull, the smaller the angle is going to get. So that means the smaller angle up here, which was 20, really belongs to this angle here, and the bigger angle of 30 really belongs to the angle here. I have 2 different right triangles. My first one is right here. X is not in that right triangle, but we can make up another variable y that is in that right triangle, and I could solve for y right now. So this is O, and this is A, so we're going to do tangent 30 equals 600 over y. So y will really be 600 divided by the tangent of 30. 600 divided by tan 30. I get 1039.23. So this is the A scenario where you will actually have to use a number you just got combined with the other number. So the bigger triangle was this big one with the 20 here. This side is still 600, but this bottom is really the y and the x together, or x plus what I just found is 1039.23. So if I have O and A again, we're going to use tangent 20 equals 600 over x plus 1039.23. So the variable's on the bottom, so it's going to be the bottom, which is x plus 1039.23 equals 600 divided by the tangent of 20. On my calculator, 600 divided by the tangent of 20 is 1648.49. And then if I subtract the 1023.23, I get 625, don't know why I keep putting decimals where they don't belong, 0.26 feet. There will definitely be problems like this. This is technically a system of equations because there were two variables and one of the equations required both variables. We're just solving it using substitution. We're solving one equation first and then plugging it in to find the other. So you're going to try this one. Pause if you'd like. I again highly recommend trying this problem. Answers are posted online, but that is the end of 9.4 and 9.5. Part 2.